Hello friends, today's question. A vessel contains oil having density of 0.8 gram per meter cube over mercury density 13.6 gram per meter cube. A homogeneous sphere floats with half of its volume immersed in mercury and other half in the oil. The density of the material of the sphere in gram per centimeter cube is. So we have a vessel and it says that the oil is over mercury. So let us suppose this is our mercury, and above this we have oil, and it says that there is a sphere with half of it's in oil and half is in mercury. So let us draw the sphere. So half is in the, you can say, mercury. So this is our mercury and other half is in the oil. Okay, so this is the oil. So this is the oil. So half of the sphere is immersed in oil and another half is mercury. We are given the density of the oil and mercury and we are supposed to find out the density of the sphere. So this is our sphere. So in this case we are going to use the concept of buoyant forces, and buoyant force will be equal to the weight of sphere. We are going to balance it and solve it, and it is going to give us the density of the sphere. So first of all, let us find out or discuss the buoyant force. So buoyancy forces. So here we have two liquids, oil and mercury. So the buoyant force will be the sum of the buoyant force because of the oil and because of the mercury. Okay, we can say that total buoyant force is sum of buoyant forces due to oil and mercury. And it is said that the volume of sphere is equally divided in both. Half of volume is in the oil and half of the volume is in the sphere. Okay. So we can say from here that each force, here force means the buoyant force, so each force is equal to the amount of liquid displaced. So herein liquid in one case will be oil and another case will be the mercury. So you can say that buoyant force FB will be equal to volume of the oil multiplied by the density of the oil G, and another portion will be because of the mercury, volume of the mercury, density of the mercury, and G. And in the question itself is mentioned that half is floating in mercury and other half in the oil. Okay, so you can say since half of sphere is in oil and half in mercury, therefore volume in oil or volume in mercury will be equal to V by 2. So we can say that volume in oil will be equal to volume in mercury, which is equal to V by 2, where V is the total volume of the sphere. V is total volume of sphere. So substituting this value in FP equation, we can write that our FP will, this is V by 2, will be equal to V by 2 we can take as common along with G, and here we are left with density of oil plus density of mercury. And now we are going to find out the weight of the sphere, and we say weight of sphere will be equal to, let us suppose it is written as Fs, and we get this as volume of sphere, that is V, density of sphere, and G. So we already know that buoyant force will be equal to balanced by the weight of the sphere. Buoyant force will be equal to weight of sphere, or buoyant force will be equal to the amount of liquid displaced by the sphere, and the amount of liquid displaced by the sphere will be equal to the weight of the sphere. We substitute the formula, so we can say from here that our FP is equal to Fs, and we can say that our Vg divided by 2 is equal to density of oil plus density of mercury is equal to V density of sphere multiplied by G. So Vg cancels out, so we get that density of sphere, rho sphere, is equal to 1 by 2 density of oil plus density of mercury, and both values are given to us. Density of oil is given as 0.8 plus mercury is given as 13.6, and this comes as 1 by 2 multiplied by, this will be 14.4. Therefore density of sphere is equal to 7.2 gram per centimeter cube. So this is the density of sphere, this is density of sphere, and the option available to us from here, we can say option number C is the correct option. You can write it here that option C is correct. So this completes the question. Thank you.